So Web3, blockchains in particular, aren't really a good fit for Web2. Many companies like Amazon and Google run them on virtualized infrastructure, which slows down the performance. And those virtualized infrastructures are designed to be able to easily be shut down and restarted. But these are distributed blockchains that are persistent and stateful. They don't want to be just shut down and killed. There's a process to shut them down. Furthermore, when you look at the way clouds are designed for Web2, they charge for egress. So every time you have data coming in or out, you're paying extra. So not only are you paying a monthly fee for the hardware that you're renting, you're also paying for the bandwidth that you use. And historically, when you go even back to Web 1, you would co-locate a server, you pay for the pipe. So you pay a flat monthly fee, you get 10 gigabit connection, and you could use as much or a little of that as you want. So coming back to Web3, these stateful databases aren't really well suited because the fees are super high, the performance is low, and then when you look at running them yourselves, the tools that you have are only Web2 tools like Docker and Kubernetes. And these things have their own problems. So Docker, for instance, could add as high as a 3 to 4 millisecond latency to network calls because of the virtualized routing it has internally. Kubernetes takes a whole team of almost doctors or PhDs to run because it's so complex and it's designed to handle a bunch of stuff. But again, historically, those are all designed for ephemeral web services, things that can spin up, spin down, be killed. But when you're running a validator and you have tokens that are staked, killing it right in the middle of something important could actually cost you money. And so again, they're just not well designed. The pros of virtualized infrastructure are that a big company like Amazon could run a bunch of virtualized computers on one computer, or in their case, thousands of computers. But the reality is that the customer could feel like they have their own machine. But the cons are you take a huge performance hit. And also when you need performance, it costs a lot more because a lot of these virtualized services, again, were designed for Web 2, where we have many different web services and ephemeral services that can be spun up and spun down. But when you have a blockchain, it needs a hardcore set of dedicated resources, especially if it's staked, if it's a validator. When it gets elected and it's in consensus and it's processing transactions, it needs a lot, and then it scales back down. And so virtualized services, you use them, you pay for it, whether you use it all or not. And oftentimes you'll see a lot of problems in latency in the networking stack and in the disk IO and things that these blockchains really need to be performant. Bare metal is when you actually have full control over the machine. So in the cloud, and you get like an EC2 instance, and they might call it like an XXL, whatever, you don't really have bare metal, you have a virtualized computer. So you're getting a fraction of the actual underlying computer's resources. And by bare metal today, what we typically mean is that you are running something on the actual computer itself with no virtualized services, you have access to the underlying OS, and usually what that means is you get a ton more performance. And typically when you co-locate or you use a bare metal service provider, you're going to pay a lot less than you would in the cloud, especially because many of those come with a dedicated internet connection that you pay a monthly fee for, and you get a dedicated connection like 10 gigabits or 100 gigabits. You're not paying for bytes in or bytes out or any of these other hidden egress fees that you find in the cloud. So we're seeing a lot of companies, even in the Web 2 space, going to bare metal. But in particular for Web3, we're seeing tons go to bare metal because the cost is much lower, the performance is much higher, and these blockchains really need as much performance as they can get. So the reason why bare metal typically has less cost is a couple of factors. One is that when you run something and you get more performance out of it, it typically means it uses less resources because it's faster, it's getting more performance. The other thing too is that because it's able to do things faster, it's able to perhaps get more return on investment, process more transactions, whatever, but it's able to just do more faster, and the throughput, we can say, is much higher. The other thing is that when you go to bare metal, you get a dedicated internet connection, and this is where the cloud really starts to add up. Is not only are you paying a monthly fee for a virtual computer, but you're also paying egress fees. So any data coming in or data coming out, you typically get another shocker bill that you have to pay for. And in blockchains, you can't control that because it is a P2P network. You know, if you have a fully synced node, it's going to share its data with other nodes that aren't fully synced. And so you don't really have any control over the amount of data it uses. And so this is why a lot of companies in the blockchain space are migrating to bare metal, because it's a lot less expense on the throughput of data and a lot less expense on the data coming in and out.